Since the dawn of time, the instinct to capture and record images has been a defining characteristic of mankind. So the Gutenberg printing press, for instance, allowed man to reproduce images of words, but it had a transformative effect on society. And nowadays, advanced lithography steppers for the semiconductor industry are doing the same thing and making the circuits that power computers, smartphones, and the world around us. Our technology combines those two threads, and it allows us to create images at the smallest size scale that you can resolve with visible light. But it allows you to mass produce them and make them at volume, which distinguishes it from other technologies.
So our invention falls into the realm of advanced manufacturing, particularly for micro devices. Those are traditionally made with two-dimensional type masks, and those features are planar. Blair takes this into more dimensions, so that you have structures like antennas, other types of things that can interact with matter in interesting ways, to do things like 3D displays or AR, VR type glasses.
The way Blair works is a two-step process. The first step is a lot like your commercial 3D printers. The way it works is you take your digital data, you load it into a machine like this, and what it then does is it writes your structure, but instead of your standard millimeter or centimeter scale that your 3D printer might be working at, this is able to write things down at the micron scale or even sub-micron scale. What we then do is we take the pattern out of this machine and we go ahead and pyrolyze it. It's a fancy word for saying that we put it in a really hot oven. This shrinks it down over 99.9%, going all the way down to the single-digit nanometer in thickness. At the end, you have a stamp that you're able to use for things such as rapid fabrication and replication. This reduces your time from being able to make these masks from weeks and a very high and large financial cost to something that's be done in hours.
Fabricated devices are not pixelated. They're true grayscale, and so you can really get the finest definition in your 3D micro devices. Before, these were privy to large technology companies with huge investments, and as they've seen our simple solution to this problem, they've expressed a lot of interest in this technology.